Okay, so we now come to the last edition of section 7.4. This should be lecture 13. Let's get started. I'm just going to do a couple of problems today, 3 problems, and that'll be it. So the first problem I'm going to do is number 16 in the exercises of section 7.4. And that's the integral of 3t minus 2 dt over t plus 1. So this is how I propose we do problems like this. The bottom is just a single linear factor. I propose that we break the integral up into, well, I don't propose that. I propose something else I just realized. I just suddenly saw, as I was writing down the problem, there's an easier way to do this. Namely, we want to somehow get rid of the denominator, and I suggest doing a substitution, u equals t plus 1. Let's see what happens when we do that. So then du is dt. Now we have 3t minus 2 on the top, so let's solve for t. T is u minus 1, so let's substitute. And we get 3 times u minus 1 minus 2 du over u, which is the same thing as the numerator becomes 3u minus 5 over u du, and that's the same thing as, I'm going to break up the fraction of 3 minus 5 over u du, and that's the integral of 3 du minus the integral of 5 times the integral of du over u, which is the same as 3u minus 5 ln absolute value u plus c. And that gives, if we resubstitute the value of u, we get 3 times t plus 1 minus 5 times ln of absolute value t plus 1 plus c. So you didn't need to go and do any partial fractions to do this. The book, if you would just apply the method of the book, you would have to do a long division of t plus 1 into 3t minus 2, and that's going to be kind of messy. I don't think that's as easy as what we did, so this was actually a much better way to do it. Okay, the next problem is a bit more difficult. It's number 20 in that section, and it's the integral of x times 3 minus 5x dx over 3x minus 1 times x minus 1 squared. Okay, so we're going to need to do a partial fraction expansion. And so let me write the integrand as x times 3 minus 5x over 3x minus 1 times x minus 1 squared. So the bottom is written as a product of linear factors, but the second of the linear factors is repeating with multiplicity 2. So this should be a over 3x minus 1 plus b over x minus 1 plus c over x minus 1 squared should be the format of the answer. So now we just apply the partial fractions method. We multiply both sides by the denominator on the left, and we get x times 3 minus 5x is equal to a times, I guess, x minus 1 squared plus b times x minus 1 times 3x minus 1 plus c times 3x minus 1. Okay, so now we have to solve for a, b, and c, and I'm going to use test points for that. So one of the test points I can use is, of course, x equals 1. So on the left side, if I substitute x equals 1, I get 1 times 3 minus 5 is equal to, well, the first term vanishes, the second term vanishes, and the third term becomes a 2c. So that tells me that 2c is equal to -2, so c equals -1. Let me box that off. Okay. What about the next test point? Well, the next obvious test point is x equals 1/3. So if x is a third, the left side of the equation becomes a third times 3 minus 5/3, and the right side becomes, okay, so 1/3 minus 1 is 1/3 minus 3/3, which is -2/3. We squaring -2/3, we get 4/9. So we get 4/9 a plus the b term cancels and the c term cancels, so we're left with 4/9 of a is equal to 1/3 times 3 minus 5/3. Now 1/3 times 3 minus 5/3 is what? Well, 3 is 9/3, so 9/3 minus 5/3 is 4/3. 4/3 times 1/3 is 4/9. So 4/9 is equal to 4/9 of a times a, so that we get that a is equal to 1. Okay, so now we know what a and c are. Now we have to compute what b is. So I've run out of obvious test points, so what I'm going to do is I'm going to just take x equals 0. So the left side becomes, when x equals 0, 0, and the right side becomes a, and then plus b times -1 times -1 plus c times -1. And this equation is saying 0 equals a plus b minus c. But we know what a and c are. A is 1 and c is -1. So we're going to get a +1 there. So that tells me that 1 plus b plus 1 is 0, so that b is -2. Okay, so now we have the actual constants. So I'm going to erase the parts of the whiteboard we don't need anymore. We have the value of the constants. We just have to remember what they are. So I'm going to first put those values in. So A was 1. B is -2, and C is -1. And I'm going to erase the rest. Okay, so the integral then takes the form, the integral that we're trying to compute is going to be the integral of dx over 3x minus 1 plus the integral of -2 dx over x minus 1 plus the integral of minus dx over x minus 1 squared. Or if you like, let's bring the constants out. So there'll be a -2 here, and we get rid of the -2 in the integrand, and similarly the minus sign. And the third integral goes outside. Okay, so now how do you do each of these integrals? Well, we can do u substitutions for each of them. So in the first case 1, the integral of dx over 3x minus 1, you would let u equal 3x minus 1. Then du is 3 dx. So 1/3 du is equal to dx. So the integral then with that substitution becomes the integral of 1/3 du over u, which is 1/3 ln of u, absolute value u, but u is 3x minus 1 plus c. So that's the first integral. Okay, so I'm going to put that above the answer we got there. It was the 1/3 ln absolute value 3x minus 1 as the first answer. We have another next term to put in. So let me put that here. I'll put it's going to be continued, that formula. Okay, so now the next integral we have to do is the integral of dx over x minus 1 squared. And for that, we're going to let u equal x minus 1. Du is then dx. Losing some screen here. Let me. Du is the same as dx. So we're going to get du over u squared, which is u to the minus 2, and it's minus 1 over u plus c is the answer to that, which is minus 1 over x minus 1 plus c. So we have a negative 2 dx over x minus 1. Oops, I did the third integral. Okay, let's leave that out for a moment. I've just computed the last one, right? So I have to compute the middle one still. Let me do that here. Okay, so I have to still compute the integral of dx over x minus 1. Well, this is just going to be ln absolute value of x minus 1 plus c. Okay, so I'm going to put all three, I'm going to write the solution down, but let me just save this screen and make more room, okay? So let me erase this. I'll erase all the substitutions I made. Okay, and I'm going to put the answer together. Okay, so, okay, let's do this over here. Okay, so the answer is 1/3 ln absolute value 3x minus 1 minus 2 times negative 1 over x plus 1. That becomes a plus 2 over x minus 1. And then minus the integral of x minus 1 squared. Oops, that's a mistake. Sorry. It should be minus 2 ln absolute value x minus 1. That's the second integral. And then the third integral is the integral of x minus 1 squared. The double negatives cancel, become a positive, and it's 1 over x minus 1 plus c. So that's the solution to this problem completely. Okay, I'll save the screen, and let's move on to the next problem. Okay, the final problem I want to cover today is number 28, which is the integral of x squared plus x plus 1 over x squared plus 1 squared dx. So this is an irreducible quadratic in the numerator of multiplicity 2. It repeats itself twice. So the general format, and I didn't really emphasize that in my lecture, but whenever you have these repeating factors, you have to put in for each power a term. So this is going to be ax plus b over x squared plus 1. It just works the same way when you have repeating factors in the linear case, except that the numerator is no longer a constant, it's a linear term. And there's going to be like a cx plus d over x squared plus 1 squared. So that's what we want to do, and I'm going to then solve the problem by multiplying both sides by the denominator on the left, and we're going to get x squared plus x plus 1 is equal to ax plus b times x squared plus 1 plus cx plus d times, well, times nothing, right? So it's cx plus d. Okay, so now there's no obvious test points to use here, so I'm just going to take, for example, x equals 0 and see what that gives us. If we choose x equals 0, the left side becomes 1, and the right side becomes a times 0 plus b is b times 1 plus d. So b plus d is equal to 1. Okay, that's an equation. What about x equals 1? We can try that, right? So 1 squared plus 1 is 3. Is equal to a plus b times 1 squared plus 1 is 2. plus cx plus d is c plus d. So in other words, if we expand this out, the equation becomes 3 equals 2a plus 2b plus c plus d. Okay, now we have to deal with I'm not finding another test point to use. I'll try x equals -1, I guess. I'm somehow wondering, maybe it's easier not to use test points. It's going to be a lot of equations to deal with here. Let me try to deal with this using the other method. So let me erase what I did. I'm going to backtrack. And what I'm going to do is I'm just going to expand out the right side. Okay, so let's do it the other way. Maybe it's easier. I don't know. So you got the left side is x squared plus x plus 1. The right side is we have a cx plus d, but let's multiply this out. So you get an ax cubed plus ax, I'm distributing, plus bx squared plus b plus cx plus d. All right, good. Okay, so what does this tell us? Well, let me combine the like terms. Ax cubed plus, what's the factor of x squared? It's bx squared plus a plus cx plus d. Okay, is supposed to be equal to x squared plus x plus 1. That tells us a must be 0, and that b should be equal to 1. That's the coefficient of x squared, and then the coefficient of x is 1, so the a plus c equals 1, and d equals 1. I think this is much easier. So what does this tell us? It tells us a is 0, so c must be 1, b equals 1, and d equals 1. So the expansion gives us b over x squared plus 1, so that's 1 over x squared plus 1, plus cx plus d, so that c and d are 1, so you're going to get x plus 1 over x squared plus 1 squared. So we did the partial fraction expansion part of this. We now have to compute the integral. I just realized in looking back on what I did that I made a typo. I forgot to include the b here in the next line. So the next line here should be b plus d. So let me fix that. And this leads to different equations, of course. So it's b plus d equals 1, b equals 1, a equals 0, a plus c equals 1, c is 1. So if you do this, what you will get is d is in fact 0, a is in fact 0, and b equals c equals 1. So I should have written, therefore, in the solution, the following expression. It's going to be a plus b, so b is 1, so 1 over x squared plus 1, plus cx plus d, so c is 1, so it's x over x squared plus 1 squared. So that's the new expression, which is correct. Okay. Okay, so with that correction, we're now ready to integrate this. So the integral becomes the integral of dx over x squared plus 1. And the second integral will be x dx over x squared plus 1 squared. So let's call this integral 1 and this integral 2. So let's calculate the integral 1 first of all. The integral 1 is easy because that's the arctangent. So that's the derivative of arctangent is 1 over 1 plus x squared. The integral 2 is we're going to use a u substitution. U equals x squared plus 1, so du is 2x dx. So 1/2 du is equal to x dx. So the integral becomes the integral of x dx, which is 1/2 du over u squared. So it's 1/2 the integral of u to the minus 2 du, which is the same thing as 1/2 times 1 minus 1 over u, or minus u to the minus 1 plus c. So this is minus 1/2 times 1 over x squared plus 1 plus c. Okay, so the final answer to our problem is therefore going to be given by, let me erase this part of the board, is given by summing up these two expressions that I just computed. So the answer is arctangent x, we'll put the c's together, plus minus 1/2, make it a minus sign, minus 1/2 times 1 over x squared plus 1 plus c. And I think that's enough for today. We've had quite a bit of practice. Take care. And so we're actually nearly finished with chapter 7. At least there are a couple more topics. And the next section is about strategy. When you see an integral, what do you do first? Which technique do you apply first? And so that's what we'll be getting into next time. Have a good one.